Hi, I'm Kelly Cervantes, and this is Seizing Life, a monthly podcast produced by Cure Epilepsy. Today, I'm happy to welcome Dr. Madeleine Oudin to the podcast. Dr. Oudin's daughter, Margot, began having seizures at 3 months old. Though these initial seizures were successfully treated, a genetic test revealed a mutation in the SCN8A gene. And shortly after, Margot began experiencing a different kind of seizure that was diagnosed as infantile spasms. Dr. Oudin, who has a background in neuroscience and cancer research, is here today to share Margot's epilepsy journey and discuss how it has impacted her laboratory's approach to research. Madeleine, thank you so much for joining us today. I am looking forward to this conversation. I have seen your name come up so many times, and I'm just very eager to chat and get to know you better. To start, though, I want to hear more about your daughter, Margot.
Well, first, thank you so much for having me. It's such a pleasure and honor as a longtime listener to be here to talk about our story. My daughter, Margot, is 3.5 years old. She loves to swim in warm water. She loves to go on walks and listen to the birds, listen to Taylor Swift and have dance parties and go to school and be with her friends. And she also has epilepsy due to a genetic diagnosis. She's had over 20,000 seizures in her life. And it's not just seizures, it comes with a range of other comorbidities related to her low muscle tone, respiratory, digestive issues, and many profound disabilities as well.
Sounds all too familiar. When did you first notice Margot's health issues?
So she had a very easy delivery and birth, and felt very confident as I entered motherhood, which was nice. And everything seemed fine until at 3 months old, I was just holding her, and she started having these facial twitches with her eyes and mouth. It seemed quite repetitive, and seemed like tics initially, I thought. And so I took out my phone and started recording, and she did it a couple more times. So we sent it to our pediatrician, who told us to go to the ER, to Boston Children's, because this looked like seizures. And so we went to the ER, and thankfully she was still doing the seizures, because sometimes something will happen and then it doesn't happen at the hospital anymore, and that can be so frustrating. But they kind of could see right away what was going on, and she got put on an EEG, and seizures were happening. And so she was diagnosed very quickly with epilepsy after that first night.
Wow, a very, very quick diagnosis, which isn't always the case. What was the treatment that was recommended? Did you get any more specifications outside of a general epilepsy diagnosis? And did the treatment work?
So initially, we thought this was completely a blip. That's what my husband and I were hoping, and we were trying to find a reason for why this could happen. She wasn't sick, but we had just started a new reflex medication, and we were, scouring the internet to find proof that this is what had caused it, and that if we stopped this, they would go away. And so, but the team was like, well, there could be different outcomes here, but we need to kind of investigate what the source could be. And they said it could be a brain tumor, or it could be some metabolic disorder, or some genetic disease. And so we were pretty shocked at kind of how serious it escalated to right away with these different options. I work in cancer research, and so I know a lot about pediatric cancers and brain tumors. That's really scary, and I was really terrified that that's what it could be. But she had an MRI, and that ruled it out. So that was not that. And then she was started on one of the, I think, common first-line medications, Keppra. And thankfully that did help, and her seizures responded right away to this initial dose. And so that also, to the team, ruled out a metabolic disorder, because if it was something metabolic, it wouldn't have responded so well. So then that kind of left a genetic diagnosis, which for us was not really imaginable at that point. You think, no, of course there's nothing wrong. There's got to be some other explanation to this. And, as my husband and I are both scientists, and we, we're okay to undergo genetic testing. We always feel more information is good. And we thought, sure, we will do this, but we were pretty confident that nothing would show up, everything would be fine. We would go home, get off this medication, and pretend as if this had never happened. But I think at this point, the clinical team were like, there are seizures. You do need to, stay close by, make sure this medication is working. I think we had a lot more confidence that things would be okay, but still a lot of unknowns at that point in time.
Yeah. So, I mean, it can take a while to get genetic testing back. In the meantime, she is on the Keppra, and is she hitting milestones at this point that you would expect her to hit?
So yeah, when we had after the admission, we had her 4-month kind of the checkup with her pediatrician, and that's where it became clear that she was not hitting her milestones. The doctor was showing me pictures of kids like holding their head up and pushing up, and I was like, yeah, no, she definitely does not do any of that. She wasn't making really good eye contact either. I think it'd be hard when seizures start that young because they don't have that many milestones yet. So it can be hard to say whether, is it really a delay or is it, something more serious? And so, but I think by the 4-month mark, it was clear there was something going on. And so that definitely kind of came as a shock for me as a first-time mom. There were clearly, some delays. And so we did get connected to early intervention right away to start some therapies. Our pediatrician was trying to reassure us that she was just being proactive and that, it could be that she wouldn't need it, but it's better to just, have the support that you need. And, that maybe these delays were just due because of the seizures in the admission and that, she would catch up. So, we started to kind of see and, observe more that, yes, there were clearly some delays that were happening. But her seizures were controlled for a little bit. So at least, they were not kind of coming back right away. So again, I think my husband and I tried to stay very optimistic and confident that, this would soon be behind us.
Yeah. Yeah. I mean, knowing that the seizures were seemed to be under control by the Keppra, I'm sure that had to be a huge sort of boost of confidence, if you will. How old was Margot when you got the genetic test results back, and talk to us about what those said?
So we got them back when she was almost 5 months old, about 4.5. And so it was pretty quick from the admission. And yeah, we were completely shocked. When we got the diagnosis, he told us what it was. We really wanted to know. My husband and I, again, are both scientists. And so, we felt that we could, look things up ourselves, and we didn't want to be waiting for weeks because they had offered for us to meet a genetic counselor, but that was going to take another month. And so I was like, I cannot wait this long. So we got the diagnosis that Margot had 2 mutations in the SCN8A gene, which codes for a sodium channel in the brain. And so, the electrical activity in our brain is regulated by a balance of things that excite the brain, that transmit signals, and things that kind of damp down the brain. And this balance is really important and is largely maintained by ion channels and sodium channels, which is what the SCN8A gene codes for. And so when you have mutations in those, that can lead to an imbalance in this kind of excitatory versus inhibitory activity, and that can lead to the seizures. And so it was a clear cause for her seizures. And, we started looking things on the internet, of course, and, there was a lot of information. SCN8A is a gene that was discovered in the 90s. And so, scientists have been studying it for a long time. And the first mutation in a patient was published in 2013, so about 10 years before. And we are lucky to have a great community in the SCN8A gene and lots of active research ongoing. So we did find lots of information. There are 2 foundations that are for families with mutations in this gene, the SCN8A Alliance and the Acute Syndrome Foundation. So we were able to join the Facebook groups and meet with families and, really read a lot of scientific papers on kind of what this was about. The thing that was hard is that there's such a spectrum with SCN8A. And I think that's the case with many genes that cause epilepsy, where, you have this community and you all have mutations in this gene, but some patients, have milder effects or effects more that are behavioral, like autism, intellectual disability, versus some that have, severe epilepsy, severe delays and disabilities. And so it can be a little bit hard at first because you see the spectrum and you just have no idea where you're going to fall and, how to kind of take in the breadth of like what could be happening to your child. So I think while it was comforting to meet people and know that there were people who knew a lot about this, it was still hard to know exactly what that meant for us and for Margot.
Yeah. Finding community, I think, is such an important part of anyone's epilepsy journey. But it's so hard, even, so many people really, really want that genetic diagnosis. Our family was one of them, but that doesn't mean that you necessarily have all of the answers. Epilepsy in general is a spectrum disorder, and even with a genetic cause, it's still a spectrum. It's not everyone has the same variant. In fact, most people have wildly different variants, but all in the same gene. And so, yes, you have an answer, sort of, and you have this community, but it just opens up so many more questions for you.
Hi, this is Brandon from Cure Epilepsy. Do you have questions about seizures, medications, treatments, or other areas of epilepsy? Cure Epilepsy's new video series, Epilepsy Explained, provides answers to help you better understand the basics of epilepsy. Each month, a different expert offers short, easily understandable answers to questions from our community about a particular area of epilepsy. Doctors and researchers who are leaders in their field will cover questions about seizures, diagnosing epilepsy, medications, surgery, and many more topics. New episodes of Epilepsy Explained will be available on Cure Epilepsy's website and YouTube channel on the third Wednesday of every month. Now back to Seizing Life.
Unfortunately, I know that Keppra didn't keep Margot's seizures under control permanently. Can you talk to us about when you first started seeing the infantile spasms, what that diagnosis was like, and if you knew anything about IS?
So that's where I think we were lucky that we got the diagnosis quickly, is that when we started reading papers, and again, because my husband and I are scientists, we looked up publications and we found that a lot of patients that had mutations in the region that Margot had her mutation had infantile spasms. And I kept seeing this in papers and I had no idea what it was. And so I looked it up and I saw the videos and I saw what it looked like. And so I knew what it was. And then within a few days, she started having them.
Days.
Yes.
Wow.
And so I, immediately knew what it was, thanks to having read these papers. And I was able to, email our neurologist and say, I really think she's having infantile spasms. Sent the videos in. We got in for an EEG right away, which confirmed she was having spasms and had the hypsarrhythmia background chaotic EEG that is associated with that. And, they started really aggressively. She was having 150 a day or so, these clusters of 10 to 20 spasms, just really obviously happening. And so we got connected with the Infantile Spasms Clinic at Boston Children's and immediately started on the first line treatment, which is the oral steroids. And that was quite a shock because I remember my husband going to the pharmacy to get them. And the pharmacist was like, this must be wrong. This is not a dose that's appropriate for a child of that age. And we were like, well, we think that's the right dose. I don't know. And so just hearing kind of the shock of the pharmacist of kind of what this treatment is. And she had to call the neurologist to, confirm that this was the right dose. And so we knew this would be intense. And steroids are a really horrible treatment for our children. The steroid rage, in a 6-month-old baby is really hard. Margot's absolutely miserable, hungry all the time. And the hardest thing was that it didn't work at all. Nothing, there was no effect of the steroids. And so just kind of sitting there, counting them, keeping track, and just realizing every day that they're just not going away, and starting to learn more about, how devastating these are. And so, we then started the next kind of standard course of treatment with vigabatrin, an equally scary medication, and all the forms that we have to sign and the risks that can be associated with it. But, hopeful that this would help. And it did help. Her spasms did come down, and she was not as miserable kind of coming off the steroids. And she did, smile a little and engage with us, which was really nice to see. But, she was still having some here and there. We only had, a week or so with really no spasms, and, they came back. And so then we did the other steroid treatment, the ACTH injections, which for her were thankfully not as bad as the actual oral steroids in terms of kind of making her, as miserable. So that was good. It was not as hard. And that helped. Again, we got, I think, about 20 days of spasm freedom with that treatment. And so that was really nice, and took advantage of kind of every moment that when your child is not having them. But then they came back again. And so at that point, we decided to start the ketogenic diet, and got admitted to start that. And, that did help. So on the ketogenic diet, you slowly kind of go up on the amount of fat in the diet. And as we slowly went up, her seizures were slowly going down. And the spasms over about a 2-month period kind of declined completely down to 0. And the other thing that was great with keto is that it seemed to really bring her to life. She started engaging more. She was vocalizing and just kind of responding more to us. And so it was really, really great to see her be more alive and more engaged with us. And so then we got about 2 months of spasm freedom, and then they came back again for the last time. And so there we added another treatment, clobazam, benzodiazepine, to help, and that thankfully squashed them, and was the end of our spasms, but not the end of seizures, as Margot was kind of, part of this large population of kids with spasms who develop other types of seizures. But the spasms were just really relentless and just exhausting to watch them happen. And I think it can be really hard because they seem so benign. They seem like it's nothing. And especially having the diagnosis of SCN8A, a lot more people with SCN8A have these longer, seizures, full tonic-clonic, where they stop breathing, which seemed so much scarier and more dangerous than these little spasms, who are so, tiny, and there's nothing to do, and they're breathing fine. So it was hard to kind of reconcile, this amount of all these seizures, but that were not so scary in themselves, and kind of what that meant. And I think initially it was kind of easier to think, okay, well, these are not as bad, and so maybe it's okay. But we know over time, and that these are just really terrible for the brain. So kind of dealing with that was hard too.
It was explained to me once by a doctor. A patient may have like one horrible tonic-clonic seizure a month or a week, or heaven forbid, a day. But the spasms, you're talking about 50, 100, 150 a day. And our epileptologist explained it to us as if you're turning the lights off on the brain and then turning them back on, and you have to reorient yourself, but now do that 150 times a day. And how in the world do you process anything around you? How is there any hope of being able to learn how to engage with the world around you when you're just waiting for the lights to be shut off again? But you're right, they look so incredibly benign in the moment. So I want to make sure, we sort of separate the two here. So there's the SCN8A, and there's the infantile spasms. So SCN8A is the cause, right? And the infantile spasms are the type of seizure, which I think you did a great job explaining. I think so often people think of IS as a diagnosis, and it is a diagnosis of a seizure type, but it is not a diagnosis of the cause, right? What is Margot's current state now that you've gotten through? I think some people are, infantile spasms, they give the drug and everything is okay. But for so many of these children, it's just a constant battle. They just keep coming back. And then, as you mentioned, as the child gets older, they morph into something else. So what are her seizures and what does her life look like today?
Yeah, so for her, they definitely turned into other seizures pretty quickly after we got control of the spasms, mostly tonic seizures, which is pretty common. She also has clonic seizures and some tonic-clonic seizures. So kind of a range of seizures that we've had to deal with after that. And, we've had to try overall 11 medications and the ketogenic diet in, the last 3 years of trying to have her seizures under control. And, she has not been seizure free, pretty much in 2.5 years. She has daily seizures. And for a while, those tonics were really hard to control. We had some pretty hard times with also up to, 150 tonics a day. Clonic seizures, we had to go to the ER to get rescue medication. So it took a while, but thankfully, at some point we did gain some more control. And it's been, over about 1.5 years where we're down to, 3 to 5 seizures a day or so, which, for us is really good.
Yeah, like my response would naturally was like, oh, that's great. And then I have to like catch myself and be like, 3 to 5 seizures a day is not great. Anyone else would like be panicking, right? And
Yeah.
you live through this experience and you're like, oh, 3 to 5, that's better than 150, but it's still such backwards thinking.
Yes. Yeah. And I think initially we hoped so much for seizure freedom. That's where everyone is hoping for. And, then you just realize it's just probably not going to happen. So then you have to adjust your expectations. So, these small seizures, they don't seem to affect her too much. They're pretty short. So that's really important for us, that they don't upset her, or, that at least they seem to pass pretty quickly. And, we haven't been to the ER for seizures in 1.5 years as well, which is also a really big accomplishment, and being able to stay at home. So, it's still a lot, and it's still 4 medications and the keto diet. And we've tried to wean all of them a little bit to see if we could get off something, and then the seizures come back. So, we're grateful for what we have, but obviously wish that it could be a lot more. You think of epilepsy as just affecting the brain and the seizures, but it's just so much more than that. And I think even as a scientist, it took me a while to really appreciate how important the brain is. I mean, we know that, but just how much it really controls in your body. And if your brain is, too excited and firing too much and has too much activity, it just has such, profound consequences on so many of the other organs in your body that it's just really hard to understand. And so, Margot has really low muscle tone. And because of that, she has a lot of digestive issues. She eats with a G tube, needs lots of medications just to keep her GI system functioning. She also has a lot of respiratory issues. Her lungs are just not, don't have the strength to really function well, and fighting viruses is really hard. So we've spent a lot of time in the hospital due to respiratory issues. She's now using oxygen at night. It just, her lungs are just not functioning well. That affects her vision as well, where the brain is needed to process visual information. And so she has cortical visual impairment and struggles, with her vision. And yeah, she has not really gained any skills in terms of development. She does not have head control. She cannot roll over or hold anything. So, we've done a lot of therapy to try and, maintain her muscles and help her, try to access the world a bit more, but it's really hard. And I think sometimes, especially with these genetic disorders, you think, well, maybe if we control the seizures, then everything will, turn out okay and we can get development. And that does happen in many children, but in some it doesn't. And sometimes, even the times where we've had seizure control, there hasn't really been any development. And so, sometimes that mutation is just really too severe and there's really not much that you can do. And so, it's taken a while to kind of realize all of that and realize kind of where she would fall on that spectrum. And now, having kind of done a lot more work with SCN8A community, I think we know that kids who have spasms with SCN8A, tend to have worse prognoses and worse outcomes and more severe impacts in terms of, further seizures and development. But yeah, I think initially we held on so much to the idea that no, she'll be on the milder side, of the spectrum. But it's taken, kind of going through all of this to accept that and, to really focus on the things that she loves to do. And like I said, swimming in her hot tub. We just got one from Make-A-Wish, which is one of her favorite places to be, and going to school and just, really trying to enjoy life and spend as little time in the hospital as we can and a lot of time together doing the things we love.
Madeleine, I want to commend you on coming to that place where just sort of this quality of life becomes the priority, because I think it is a really hard place to get to, because we want to fight for our kids and we want the seizures to go away and we want to give them the best opportunities to live what we perceive, our perception of what a full life is. And I think that you're doing an amazing job, and that, this coming to a place where the quality of life is the most important thing is the best gift that we can give our kids. And I admire you for that a lot. All right, so we're going to shift gears just a smidge here, because I want our listeners to fully comprehend what a super mama you are. You lightly said a couple times that you're a scientist. You're not just a scientist, you are a brain cancer researcher with a lab who is now also studying epilepsy and SCN8A. That's amazing. There are when I would look at white papers and try and understand the research that had been done that might correlate with my daughter, I always had to have like Google up on the other half of the screen so that I could Google all of the words in the document, because I am not even close to a scientist. But you take that a step further and now you're researching it. And I just talk to us about that, because I think it's so beautiful and amazing, and how productive. What an amazing, I can only imagine. I want to hear from you, but bittersweet, I suppose, but to be able to take action in a lab.
Yes. So I did my PhD in neuroscience. So I've always been interested in the brain and was studying how cells move around in the brain. And cells being able to move in the brain is important for development, for cells to go to the right places. If they don't go to the right places, you can get structural abnormalities that can also cause spasms. And even in the adult brain, there are some newly generated cells that can move around in the brain and help support the brain. And so I learned that then, cancer cells move around as well. This is a process called metastasis. This is when, the cancer has spread to other organs, and that's what ultimately leads to patients dying. And I became interested in applying my knowledge of neuroscience to cancer and realizing that there were a lot of similarities. And so I actually worked on a protein that was discovered in the developing brain that regulates the development of the brain and where these cells go. And it was also then found to be involved in cancer, which is really fascinating. And a lot of what we knew about this protein in the brain, we could apply to cancer and understand how cancer works. And I realized this wasn't the only gene that did this. There's actually now quite a few genes that have roles, both in the brain, in healthy brain or diseased brain, and in cancer. And so my lab was actually working on ion channels in cancer. I mentioned SCN8A is an ion channel. There are different types of ion channels that regulate the electrical activity and this balance that I mentioned in the brain between excitatory and inhibitory activity. And many of these are also dysregulated in cancer. So we were studying, these ion channels in cancer when Margot got her diagnosis. And so these similarities are just really fascinating. And as now I've been more learning about epilepsy, we're finding a lot of mutations in epileptic tissue, like in adult patients that have surgery, in mutations in genes that are really famous in cancer and that are really well known. And so, I think it's really exciting to see these similarities. And it's not surprised because the human body, will try and repurpose things from other organs that it can know how to do to, drive disease. And this can, lead to really exciting opportunities in terms of drugs. So, recently there was a drug approved in cancer targeting this mTOR pathway, which is now being used in epilepsy to treat epilepsy patients. And vice versa, the keto diet, which has been used to treat epilepsy for many years, is now in clinical trials for cancers. And so, these similarities, there's a lot that, each field can learn from each other. And maybe we can repurpose drugs that are already FDA approved for one disease and maybe can be used for another. And that can help drugs get more quickly to patients and give us more options of things to try. So it's been really interesting to see these similarities and the potential. And so, but, as I got started, when we were dealing with Margot's diagnosis, as you said, it was just very frustrating to not be able to do anything, to just, watch the seizures and wait and count and just try. And I just, we did all this therapy and not really seeing progress. And so I was like, well, I need to do something because I feel so helpless. And so maybe starting research can help. And I was very lucky that my university at Tufts is actually really strong in epilepsy research and has some great researchers. And so I connected with Professor Chris Dula, who's done a lot of work with Cure, done lots of work on infantile spasms. And for the funny story, one of my graduate students was dating a graduate student in his lab. And so we connected and I told him about Margot's diagnosis and initially just kind of wanted to chat, but he was like, well, if you want to do anything, like, let's, I'm happy to help. And so then I kind of said, well, maybe I should try and start some research in my lab and, collaborate with him and with my husband as well, who's a professor at MIT. And so, over time, we decided to just start research and in collaboration and with this team to just start looking at SCN8A and, just try and do something. And so we started, 2.5 years ago. We've also recruited other researchers from that we know that work in our respective fields to help us and to bring more people to SCN8A and epilepsy research. And yeah, it's been definitely really helpful for us to feel like we're doing something and have some bit of control over certain things. And it's been really exciting to contribute.
Yeah, very beneficial to be at Tufts, where one of the top IS researchers is, and you can bounce ideas off of each other. There is something so incredible about, and your brilliant expertise crossing over with the epilepsy and seeing all of these parallels. It gives me a lot of hope for the future of research. So talk to us a little bit about the research, the epilepsy research that you are doing in your lab.
So we are trying to develop a novel therapeutic for SCN8A and generally trying to answer the question, can we correct the brain? If we can fix the genetic mutation that causes the spasms, the seizures, the developmental delays and issues, if we fix the source, can we, how much of an impact can we have within a patient? And, when is the right time to intervene? Can you still, if you intervene at a later time in life, can you still fix the brain and have an effect on development and seizures? And so, these are really big questions in terms of the new genetic therapies that are being developed in epilepsy and for neurodevelopmental disorders as a whole. And there's a lot of exciting work being done trying to target the source, the DNA, where the mutation is that is causing the seizures. But some of those treatments can be quite challenging to manipulate the DNA, to do that in a safe way, to do that in the brain. And so, there can be challenges there. And so we've actually turned towards targeting RNA, which is the kind of a next step. So in our cells, we have the DNA, which is where any mutations would happen, but the DNA itself doesn't do anything. The DNA makes RNA, which then turns into proteins, and the proteins are the ones that are doing something. And so it's the protein that is made that regulates the activity, for example, of the neurons, like for Margot's mutation. So this intermediate is the RNA, and there's a novel therapeutic class called antisense oligonucleotides, or ASOs, that were developed about 8 to 10 years ago to target the RNA and correct the protein in some way without having to touch the DNA. And the advantage of these for epilepsy and neurodevelopmental disorders is that you can inject them in the spinal cord and they go to the brain, just like an epidural. So it's really quite straightforward to get these therapies into the brain by injections every few months. And so there's a lot of different ASOs being developed for different genetic epilepsies right now, exciting clinical trials ongoing for a range of genes. And really trying to see, well, okay, can these treatments, again, that kind of try to correct the source, be better than the seizure medications that we have? And can they not only reduce the seizures, but also help with all this other stuff that happens with the seizures? Because maybe by correcting the source, we can have a bigger impact. So it's really exciting to, be doing that work. And we use cellular models, we use mouse models. We've created a mouse with Margot's mutations. We affectionately call the Margot mouse, that has, very severe epilepsy and also the low muscle tone. And so it's good to have these models that can really recapitulate the human disease and test these treatments and, see, again, if we can correct the source, what kind of an impact we can have.
So freaking exciting, first and foremost. But I also know how long research takes to get from a lab into a human. What does, assuming everything works out and your science passes all of the qualifications and the bars, what does this process look like in terms of years?
Yeah, so it takes a while because you need to, again, usually get data in cells first, then it's good to get data in human cells, and, mouse models help as well. Then you need to make sure these drugs aren't toxic and check that, they don't cause any, negative issues, usually in multiple species like mouse and rats. And, then you need to apply to the FDA. So, it can take a while. The FDA has a different path now for these rare N of 1 treatments that are genetic treatments developed for individual mutations that can allow things to go faster. But so we are hopeful that, with Margot, within the next, 2 years or so, we can hopefully get a treatment into her. And, while initially this would be directed at her, we hope that, there are other patients that could be eligible for this based on where their mutation is. And we hope that that can then be expanded. And we hope that what we're learning, with SCN8A can also be applied to other ion channels as well. And that, that can help generate knowledge to help expand this to others. And, it's still early stages and we're still learning a lot, about what can we correct in the brain? What can we even intervene? Can this make a difference? So there's so much to learn, but I think, there is a lot to be hopeful for, and that's exciting.
Well, I know there's going to be so many people who are happy to hear that, and we can all use a little more hope in our lives. I thank you so much for sharing your story, sharing Margot with us, and for the incredible research that you are doing. Few things give me more hope than pushing science forward, and I thank you for being such an active part of this community that you never wanted to be a part of, but here you are and you're a freaking rock star. So thank you.
Thank you so much for having me.
Thank you, Dr. Oudin, for sharing Margot's journey and for the important genetic research your lab is conducting to help others impacted by SCN8A mutations. Genetic and rare epilepsies can often struggle to get the research attention that they need. That's why Cure Epilepsy has created the Rare Epilepsy Partnership Award to support the development of the necessary research tools, techniques, and data collection platforms which will accelerate research on rare epilepsies. If you would like to support our efforts to advance knowledge and therapies around genetic and rare epilepsies, please visit cureepilepsy.org/donate. Thank you.
The opinions expressed in this podcast do not necessarily reflect the views of Cure Epilepsy. The information contained herein is provided for general information only and does not offer medical advice or recommendations. Individuals should not rely on this information as a substitute for consultations with qualified healthcare professionals who are familiar with individual medical conditions and needs. Cure Epilepsy strongly recommends that care and treatment decisions related to epilepsy and any other medical conditions be made in consultation with the patient's physician or other qualified healthcare professionals who are familiar with the individual's specific health situation.